Come on. Trying to get it as I'm the main view here. Okay, Jagadish, what we were talking about is we're reviewing. I'm just trying to get it so I am the main person on the screen and it's not being cooperative. Do you guys just see me or do you see the whole class?
The whole class. The whole class.
That's what I was afraid of. All right, well, let's do it this way. Let me change it. I'm gonna change what I'm doing here. No. All right. Anyhow, let me just talk about it then instead of drawing on my whiteboard for right now. Sorry about that. I'm learning some of this as I go. Google Meet is not my most favorite thing. So let me come to Jagadish. Got a question for you. If two boundaries are pulling apart from one another. Yeah, there's a whiteboard app, but I've never used it yet. And I don't want to use it for the first time without trying it. I started to send you an invite and I stopped. Jagadish, if two plates are pulling apart from each other, what kind of boundary is this? Very good. It's a divergent. I'll use my mini whiteboard. All right, so if the plates are coming together, this is convergent. Like this. Divergent is coming apart, right? Okay. If I have a convergent boundary and they form a mountain, Nolan, what kind of boundary is that? Or what is that?
A transform boundary.
No. It's a type of convergent boundary. Shrieker.
It's a convergent collision.
It is a convergent collision. Collision boundary. All right. Now this next one Ramchan, two boundary plates sliding past each other.
Sorry, can you hear me?
Yes.
Is it called the transform fault boundary?
Well, it's just called a transform boundary.
Oh, okay.
So transform boundary. Very good. All right. The only other kind of boundary there is that we haven't talked about yet is when one boundary pushes past the other and the other goes under. It forms a hot spot and then creates a volcano on top of it. Arsh, what kind of boundary is that?
Submissive?
Close. The word is subduction. All right. Now, all these boundaries make up what kind of plates, Akriti?
What do you mean by that?
Okay, so there's 15 plates on our planet. Okay. And these boundaries are where all these plates come together. What do we call all the plates?
Plate tectonics.
Right. Plate tectonics are tectonic plates. So tectonic plates. Tectonic plates. There we go. Helps if I spell it right. All right. So that is pretty much all we need to know right now about the different plates, about the boundaries. Did I inform you last Tuesday that there's going to be a test on Tuesday? It's going to be a killer, too. It's going to melt your brain. Not really. It's going to be very easy. So, what we're going to talk about today, so that was just a little bit of a review. We're going to talk about something that I like to call resource allotment. We're going to talk about three different types of resources. We're going to talk about fossil fuels. We're going to talk about metal. And we're going to talk about water. These are the three things I want you to know the most about. All right? So the first one we're going to talk about is fossil fuels. Yay, fossil fuels. So Viraj, tell me, you can either type it or tell me verbally, what is fossil fuel? What is it?
It's like something that we can find like inside of the earth that we can use, but it's not always usable.
Okay. That's not exactly telling me what it is. So, Sahana? Sahana, are you there?
Can you hear me?
I can hear you.
Okay, I'm here.
Do you know what fossil fuels are?
Well, I a rough little description. So,
Well, no, just tell me what a couple fossil fuels are.
oil
Okay.
and coal.
Yeah.
That's those two I know.
Well, that's the two. Those are basically your fossil fuels. Now, petroleum, aka oil, is responsible for a lot of the fossil fuels that we use. I take oil and I boil it. When I boil it, I get gasoline, I get kerosene, I get propane, methane, I get all these different kind of petroleum distillates out of it. So it makes a lot of different things. I make diesel fuel. Fossil fuels, are they important to us, Carson? Do we need them?
Yes.
Could we live without them?
We could live without them, but life would be a lot harder.
You know, true, we can, but I think our population would decrease quite a bit. Because you think about it, we live in an area, Northwest Arkansas, do we really want for anything? We have plenty of food, don't we?
Yes.
You know, you go to the stores are full of clothes, the stores are full of electronics and all this stuff. We eliminate fossil fuels, there goes our food. There goes our electricity. There goes our clothes. There goes our electronics. Because, guys, we don't make enough food in this area to support all the people that live here. If you live in a city, you have to ship your food in. And how are you going to do that? You're going to do that on semi trucks. You're going to do that in trains. You know, most of our electronics and our clothes, are they made here in the United States? No. We ship them over in huge ships. Now, sure, can I sail a ship without oil or fuel? Sure can. A sailing ship. Can I carry that much stuff on a sailing ship? Will it get here anytime soon? If I have a horse-drawn wagon, am I carrying very much stuff? Not to mention, can I freeze my food without electricity? Well, the majority of our electricity comes from the use of coal, a fossil fuel. So fossil fuels are extremely important to us, right? And we've already mentioned that it's non-renewable. Yeah, it is. It's renewable, but it's going to take you approximately 100 million years. I might still be alive because I'm immortal. I'm super old. But most of us are not going to be here that long. So the question now comes, Daniel, how do we get fossil fuel?
We pump it out of the ground.
Okay, let me rephrase that question. Because while you are correct, we pump oil out, we don't pump out coal. How is fossil fuel made? Would be a better question, I guess.
From like some dinosaurs, like the fossils
Okay.
from like a long time ago.
Austin, can you add anything to that?
Can you hear me?
I can.
No.
Okay. How about you, Shrieker?
heat from the sun was like absorbed into that dead and decaying matter, which then created our like coal and oil that we get from the ground.
So it comes from organic biomass. So the number one thing people say when I ask them where do our fossil fuels come from is dinosaurs. Well, unfortunately, there wasn't even close to enough dinosaurs on this planet to make all the oil and coal that we have here. Okay? But there was enough organic material. Have any of you guys ever just walked through the woods? You know, you start walking under trees. You know, we're getting this time of the year where the fall leaves, they're going to drop off the trees, right? So all this material falls on the ground. Like Abigail said, dead animals and the dead dinosaurs from a long time ago, they die. More stuff falls down on top of them. And what happens is this stuff starts compressing itself. It starts smashing it and smashing it and smashing it. And have any of you guys ever been in a dog pile? A dog pile is where, you know, somebody falls on the ground and somebody runs and jumps on top of them, and then somebody jumps on top of them, and somebody jumps on top of them. You know, everybody just kind of like jumps in a big pile. Well, the person on the bottom, they start to get smashed, but they also start to get hot. And the reason why is that pressure starts to build heat. So as all this heat and pressure build together over about 100 million years, it converts all this dead organic material into fuel. Whether it's hard and solid like coal, or whether it's liquid like petroleum, it converts it into fossil fuels. Now, Shrieker was saying something about the sun heats it up. Well, Shrieker, you're not that far off, but the sun actually plays a very critical role in this, but not that it heats up the organic material, because by this time, this organic material is buried deep underground. All that weight is smashing it, so the sun doesn't do anything. Juliana, what does the sun give us?
It gives us light and heat and radiation.
Right, so do I get energy from the sun?
Yes.
How?
Not really sure how to describe it.
Do I go outside and go, "Ah," and it charges my body up?
Vitamin D.
No.
Yeah, that's what it is.
Say that again.
I said your skin soaks it up and turns it into vitamin D.
Yeah, that's vitamin D. That's not energy. Harrison, nice to see you joining us. Do you know how we get energy from the sun? It's a cool little thing we're going to talk about a lot here soon. I ran out of room on this. Photosynthesis. All right. Plants convert sunlight into energy, and they store it in something called glucose. So the energy that powers my body comes from plants, which got it from the sun. All right. So all this organic mass, all this plant matter that falls down on the ground, all the dead animals, they still have this glucose sugar in their bodies, in their cells. And that is converted into the fossil fuels. So when I go to Casey's and I pull up to the fuel pump and I put it in my car, I'm actually putting energy from the sun into my car. 100 million years in the making. Does that kind of make sense? So it takes a lot of biomass, though. A lot of biomass. A lot of biomass. Plus plus 100 million years gives me fossil fuel. Hint, hint, nudge, nudge, wink, wink. That will be on your test on Tuesday. All right. A lot of dead organic material and a lot of time is needed to make fossil fuel that we have to survive. And really, we need that to survive now because we live in such large areas and we bring our food in from so far away. We have to have that petroleum. We have to have that coal. We have to have that electricity. Arsh, you have a question, sir?
Can we also use solar panels?
We can, but right now, we don't have the ability to use solar panels to move a 90,000 pound truck 700 miles within 24 hours. Okay, so eventually, hopefully, the technology will come that we are not so dependent on fossil fuels. But if fossil fuels went away today, we'd be in a lot of trouble because we don't have anything to replace it right off the bat. Does that make sense? Okay. Elijah, you had your hand up. You had a question?
No, something that is related to the solar panels.
What's
So,
that?
if our solar panels that we have today even get to the point where they can move a 90,000 pound truck, however many miles in 24 hours, I forgot what you said, we'd have to use a ton of materials, like rare materials.
Right, rare
Solar
earth
panels
metals.
aren't exactly clean either.
Yeah, I mean, there's a lot of problems with those, but I mean, technology keeps getting better. You know, hopefully one day it's there. Hopefully for your sake it's there because we probably only have 20 to 30 years worth of oil left and then it's gone. So, you know, we're running out of the stuff. You'll face that in your lifetime. I am either going to be so old I'm not driving or I won't be here anymore. You know, it's if I'm 90 years old, I really don't want to be driving down the road. Or maybe I do. You don't want me driving down the road. Okay, the next thing I'm going to talk about is metal. Metals are things like copper, iron, silver, gold, just to name a few. Now, metal is also extremely important to us. We need it for electricity. You know, all the lights in your house, copper. If it wasn't for copper wiring, it wouldn't be there. Solar panels. We need rare earth elements, which are metals. We need those. We need the copper, the silver to do all our circuitry. Metal is also extremely important. Well, there's 3 different ways that rock is formed. The first one is sedimentary rock. All right. Sedimentary rock is rock that forms in layers. You know, sediment drops down on the bottom of the ocean floor, it hardens, more falls down on top, it keeps building, building, building. If you've ever seen a picture of the Grand Canyon, have you ever noticed how the Grand Canyon is striped? That's because it's sedimentary rock. This is usually sand, silt, just a small collection of a whole bunch of stuff all together. The next one is metamorphic. Metamorphic rock. This is where I mix a couple different kinds of rock together and it gives me these different kind of patterns. Imagine getting red, blue, and green clay, getting it together, squeezing it, twisting it, kneading it, and then pulling it out. You get this kind of swirly tie-dyed color, right? This is like marble. Very good, Sahana. Those are the three different kinds of rock. And the last one, which she mentioned already, is igneous. I always forget how to spell igneous. That looks right, or looks pretty close. Igneous rock, and this is the one that I really want to talk to you about. Igneous rock is made from volcanic activity. This is where I liquefy minerals at. When I liquefy large quantities of stuff, it is a natural phenomenon that, like minerals, want to gather together and bond together. Okay, so if I liquefy a lot of stuff, you're going to get carbons building together, you're going to get gold building together, you're going to get iron building together. So this groups together in large quantities. And eventually the volcanic reaction cools down and we can actually go in these areas and dig, and I find deposits of copper, I find deposits of iron, whatever it is I'm looking for. So we find our metals by looking for areas of past volcanic activity. All right. So if the Grand Canyon was not made by volcanoes, do I want to go there and look for metal? No. I want to go to some place that I know had volcanic activity at some point and start digging, and then I'm going to find different kind of metals. Anybody here ever been to the Arkansas Diamond Crater State Park? You know, it's pretty cool. You can go there, and that is or was a volcano. And as a result, one of the things are you can find diamonds there. I mean, just 2-3 weeks ago, somebody found a 7-carat diamond. I mean, that's a pretty big diamond. Actually, Jagadish, I think it's a lot better chance of getting one than that. People find diamonds at least once a month there. Small, not worth very much, but you found a diamond for like $10. This 7-carat diamond was worth like $60,000-$70,000. Yeah, I've been there 3 or 4 times and never found anything. But you know, they're finding diamonds all the time there. Who said something about Yellowstone? Yellowstone is very volcanic. The problem about Yellowstone, Viraj, is that it's a national park, so we can't dig in there for metals or anything like that. And it's still an active volcano. It's dormant.
Yeah, if that thing were to erupt, it would the like eruption zone, which is also known as the kill zone, it would be like the size of Wyoming, and the ash would be spread all across America.
How about all across the world? All across the northern hemisphere. If Yellowstone,
mine there too because of all the geysers and stuff.
If Yellowstone erupts, the northern hemisphere goes into what's called a nuclear winter. Life pretty much stops in the northern hemisphere, at least for about 5 or 6 years. The ash would cover up most of the United States, most of Europe, quite a bit of northern Asia. but the ash cloud in the atmosphere would block the sunlight out and drop temperatures 20 to 30 degrees. So yeah, we don't want it to erupt. The last thing we need to talk about, so again, understand that we find most of our metals in areas of past volcanic activity. Hint, hint, nudge, nudge, wink, wink. You are going to find that on a test. Don't worry so much about the different kinds of rock. We're going to talk about that later. But just know that we look for areas of volcanic activity, past volcanic activity, to find our metals that we need. And the last thing, really brief, is something that we've talked about quite a bit, is fresh water. Is fresh water something we could run out of? Thumbs up or thumbs down? Yes. We can definitely run out of fresh water. Do we need fresh water to survive? Sid, why?
It's like the essential thing for us. Like it's very essential water.
Why?
I think it's. I don't know.
Do I need it to do my laundry? Juliana.
Most of our bodies is actually made out of water, and we need it to stay hydrated.
Yeah. So our cells require water. All life requires water for the different processes that happen inside the organisms. Do I need it to drive my car? No. Cars don't require water. They get cooled by a radiator, but you usually don't put water in your radiator anymore because it causes your engine to rust. So you put something called antifreeze in there. Do I need it to, do I have to take a shower? I want you to take a shower. I really don't want to smell you. But guys, we didn't start taking showers till like the 1200s. You know, we went
Around where the Greek and Romans were.
Yeah, I mean, they'd jump in a pool every once in a while. But guys, we do this so we don't stink. You know, to wipe off some of that dirt. We truly don't need to bathe. I mean, I want you to bathe. Don't go and tell Mom, if my science teacher said I don't have to bathe. That's not what I'm saying. Do I need it to build a house? No. So we need it for ourselves. Can we run out of fresh water? Yeah, we can pollute our water. You know, it's very easy for us to destroy the water that we have. So is this something that we need to control and be careful with? Yes. Arsh, you have a question, sir?
So what about the water cycle? Wouldn't that just mean like the water would evaporate and then we could like it would go in the groundwater, which would like be like a water filter?
It can to a degree, but have you ever heard of acid rain?
I've heard of it, but I don't know what it means.
Okay, so we live in a very industrial civilization, correct? In the Great Lakes area of the United States, in the late 1800s, early 1900s, this was what we called the iron belt of our country. All right, we live in the bread belt because we produce a lot of food products. But the iron belt is where we started the textile. This is where we started burning a lot of coal and, you know, a lot of engineering stuff going on. factories just pumping black smoke up into the atmosphere like crazy. Well, the problem is the area to the east of there, Pennsylvania and Vermont and, all this stuff was beautiful forested area. Well, all of a sudden, this rain, this fresh water that was falling out of the sky, we were finding tons of rivers and lakes with dead fish. We were finding forests being destroyed because the water was mixing with these clouds that had pollution in them. And when it rained, it was basically raining down an acidic poison back into our ground. So can I destroy fresh water in the water cycle?
Yes.
Yes. Luckily, we've learned. We've learned that, okay, we have to clean the smoke out of these factories. So now we have things that take all the harmful stuff out of the smoke. What about, if I put what's called heavy metals into water, it doesn't evaporate as quick. I can make it so man disrupts the water cycle because, hey, we're such a great organism. We really know how to destroy our planet. We're really good at that. We are a virus on our planet, a very destructive virus. Luckily, we're getting better. It always cracks me up when I hear them say that we're destroying our planet. No, guys, we're not destroying our planet. We're just destroying ourselves. We're going to mess our planet up so bad it can't support us. We're going to die, and our planet's going to rebound itself. It's going to come back once we're not here. Anyways, I won't get on that soapbox right now. So basically, make sure that you know that we need fresh water. Make sure you know about metals and where they come from. And make sure you know that petroleum takes a lot of organic material a long time. And you should do pretty good on this test on Tuesday. There is a decent amount of you that still have not done your gizmos. I'm a little behind on my grading, but I'm going to be entering those into zeros pretty soon if you don't have them done. And that will drop your test or your grade in the class. And
Is there like a way you turn in the actual gizmo?
Yeah, you hit the turn in button after you do it.
Like I'm talking about not the pamphlet or not the pamphlet, the doc.
No, the doc is what I'm concerned about.
Okay, not the gizmo part.
No, just by doing it, it shows up on my end that you've done it. But yeah, the doc is what's being graded. And also there's a good portion of you who have not done your reading yet. And guys, the reading is really simple. The reading takes you probably about 15 minutes tops, if even that long. After Tuesday, I won't see you again until the new quarter. And all those grades will be finalized. You won't have an opportunity to fix those. So please get them done, all right? With that being said, ladies and gentlemen, we are done. You have a fantastic day.
Bye, Mr. Schillinger.
Bye.
Have a good.
Bye, Mr. Schillinger.
Bye, Mr. Schillinger.
Bye, everyone. Have a great day. A pleasure as always. No, I slacked off on that one. Decided not to give you homework today.
Oh, okay.
I'm sorry. I'll do better next time.
Mr. Schillinger, is there a study guide?
Review the video I'll post here in just a little bit.
Okay.
Hey, Elijah, I'm going to tell you 5 questions, multiple choice.
Yeah.
It's going to be really easy.
Okay. I just want to be prepared.
Understand.
just in case.
Definitely understand. What's that, Shrieker?
What's the date of the quiz?
It's going to be